Now, when we talk about the chemical nature in chemistry, what does it mean by it? When we talk about the nature, like when we talk about the nature about the people around us, we say that yes, she is very sweet in nature, right? She is very cooperative in nature, right? So we do use certain kind of words when we come across in the people in our daily routine, right? But when in the chemistry, when we talk about the nature, that does not mean the sweet, beautiful, or a cooperative one, right? What does it mean? It means the acid, basic, and the neutral nature, right? So whenever like you have to mention about the chemical nature of any substance, that means it should strike your mind at that moment that we are talking about whether it is acidic, basic, neutral, or we do have certain exceptions like you can say the amphoteric ones or like that. But the basic category which is taken into consideration is the acid and base, or you can say the neutral one, right? So what are actually those natures? What are those properties which make the given substance as acidic or basic, right? So when this chemical nature came into the you can say into the consideration in the thoughts of people, then how people used to classify the substances acid and base, they just at that moment we had only operational definitions. Like, what do you mean by operational definition? That means the definition which came into nature by performing certain kind of operations. Like, for example, if I have a lemon, right, I'll taste it and I'll say I know that it contains a citric acid. You too know that, right? So if we have the lemon and I just take the lemon, I just taste it, then I'll just have a taste of this, like that. What indicates it is sour in taste. And as we know that the lemon contains citric acid, that means we'll say that those according to those operational definition, acid came out to be substances with sour taste, right? And similarly, like I have baking soda, you know that baking soda, it contains a base actually. If I'll taste that baking soda, what feeling I'm going to have? I'll just have a feeling, a very weird feeling, because it is bitter in taste, right? So these all, from where does it all actually came? They just, those you can say the categories or the properties of acid base just came from the operations which we performed, right? That means we just look at the substance, we tasted that substance. So these are all operational definition, right? So if we take into the consideration the classical concept of acid base which give rise to the operational definition, so according to that, the substance is called as acid, which is an electrolyte. That means it conducts electricity in aqueous or molten state. And when we talk about the base, then again it is also an electrolyte. That means it also conducts electricity in state of aqueous or molten, right? Now, if we talk about the taste, then how the acid, what kind of taste we get from an acid? As I told you that like you can say the apple contained the malic acid, right? The lemon contained the citric acid, the vinegar contained the acetic acid, right? So that means those all acids, if we'll taste them, they will just what feeling which we'll get is the sour feeling. That means all acids are mostly sour in taste. And when we taste the base, they appear to be bitter. They just taste bitter, right? So these are the properties. So that means it is an electrolyte, it is to an electrolyte, it is sour in taste, it is bitter in taste. And one more property which an acid shows, that whenever ever any metal react with acid, it forms the respective product. Along with that, always the hydrogen gas is produced. But it doesn't happen in case of base. They don't produce any such kind of gas when they react with an acid, right? If we just if I'll just hold the base in our hand, what kind of feeling I'm going to have? It is soapy in touch. But the acids are not like that. They are, most of the acids are corrosive in nature. Whenever we take into the, or they just accidentally fall on your skin, what happens? It just give the feeling of burning sensation, because they are corrosive. They just extract the water from our skin, right? So they are not, they don't have that soapy touch feeling. They are actually corrosive in nature, most of them. I'm talking about the strong acid, this corrosiveness is not for the weak acid. Right. So these are the, you can say, the properties. One more property, an important property, that is they turn blue litmus red and they turn red litmus blue. The children often get confused with that which is going to turn which color litmus into which color litmus, right? So you can just try and you can say an abbreviation you can make for an acid, that for acid it is BLR, that means the blue litmus red, and for the base it is RLB, that is the red litmus blue. So you can take it as any way, you can make your own abbreviation. So just you need to learn them, because these effects are you can say the proven effects, and you need to learn them, right? So in case of acid, when the litmus, which litmus color changes to which, it is BLR, blue litmus to red, right? And in case of base, it is red litmus to blue, right? So these are the definitions which I told you are based on the operational facts, right? That means we just performed certain kind of operations, we just performed a certain kind of test, you can say, and we came to the conclusion that yes, any substance which possesses this property is called as an acid, and any substance which has the feeling of this is a base, right? But these definitions are they are proven, right? But still they don't explain much about the acid and base. So we need certain kind of theories, or we need a appropriate theory which just explain about everything about the acid and base, or you can say a neutral substance. So here we have those theories. So the theory about the acid and base, or you can say the theory about the chemical nature, was the volunteers who just gave this theory were the Arrhenius, Bronsted-Lowry, and the Lewis concept. These three theories actually, you can say there were some limitations for the Arrhenius theories which were covered by the Bronsted-Lowry concept. It was a broad concept, but still the more wider concept is the Lewis concept, right? So they are just trying to explain the, you can say, the characteristics of acid and base in their own terms, right? So we are just, you have to study all these theories, right? It's not like that you have to take into the consideration the Lewis concept leaving behind these two. No, they actually proved their results with certain kind of you can say the observation which they made, and it is very equally important to know about the Arrhenius concept, the Bronsted-Lowry concept, as well as the Lewis concept, right? So these were the operational definitions, and these are the, you can say, the proven results, right? So first we are taking into the consideration the Arrhenius concept, that how Arrhenius just explained the chemical nature of substance, in which terms he actually explained, right? So Arrhenius said that any substance when dissolved in water and produce hydrogen ion is called as acid. I think you got it. Any substance which on adding into water produce hydrogen ion is called as acid. For example, we have HCl. He said that when we dissolve HCl into water, what do we get? We get the hydrogen ion separated from the chloride ion. As you can see, there is in HCl we have H and Cl, right? So it breaks down to form H ion. So it has released the H ion, and we know any substance that release H ion is considered to be acid by Arrhenius. So this is how he explained the nature of the acid, right? And when he talked about base, then what he said? He said that any substance which contain this hydroxide ion, right, means the substance has to contain that hydroxide ion if it has to behave as a base, right? So this is the compulsion factor, that it should possess the hydroxide ion, right? So as you can see, he said that any substance which when dissolved in water give rise to hydroxide ion is called as base. I think it's clear. Any substance when dissolved in water produce hydrogen ion is acid according to the Arrhenius, right? And if any substance when dissolved in water produce hydroxide ion is base actually according to the Arrhenius, right? For example, NaOH, as you can see OH in it, right? OH is the hydroxide ion, right? So as you can see hydroxide ion, so he said when you will dissolve such kind of compound in water, it will just split and give the hydroxide ion. And we know that any substance which give the hydroxide ion in water is considered to be base by Arrhenius. So right, so that means NaOH is considered to be base by Arrhenius, right? So the first you can say the definition or the first click whenever you study about the Arrhenius concept is that if any substance on dissolving giving hydrogen ion acid, and if any substance on dissolving giving the hydroxide ion, that is the base, right. The second important thing that must be striking in your mind, that I am using this word that any substance when dissolved in water, that means no substance is just giving its hydrogen ion or hydroxide ion just like that. It gives only when it is dissolved in water. So this is the compulsion factor. That means the substance has to be dissolved in water. Then only it will result in the formation of hydrogen ion or the hydroxide ion. So this was stated by Arrhenius, right. Then he just talked about the strength of acids and base as well, right. So how he talked about that, he said that when any acid, say I take an example, the acid general example, you can say the formula for acid as HA, right. So if any acid when on dissolving gets completely dissociated into ions, it is called as strong acid. Now what do I mean by it? I mean by it that I took this acid, I dissolved in water, that is the important factor, right. So when I dissolve this acid into water, what we get? We get the hydrogen ion and the other salt or anything which is present along with it, right. So if it is you can say if we add HA into water, if we'll get only H and A, that means we are not getting the HA molecule in the water. All the HA molecule got dissociated into H positive and A negative. So that means any acid which completely dissociate to give all its hydrogen ion is considered to be strong acid, right. So like HCl, all mineral acids actually fall under this category. These are all strong acids. When they are dissolved in water, they just dissociate to give all their hydrogen ions which they possess, right. So he said that those acids which completely dissociate are called as the strong acid. There don't exist any unionized you can say the molecule, all are present in the ionic form, right. And those acids which dissociate to form ions, and as well as we are able to see the molecule present in the, you can say the unionized molecule present in the water. That means this molecule gets partially dissociated. That means all the hydrogen ions present in it is not given or not, this molecule is not actually dissociated into all H ions. It is dissociated but partially dissociated, right. So that means it is considered as weak acid, right. I think it's clear with the strength when we are talking. So any acid which completely dissociate to give all its hydrogen ion is considered to be a strong acid, and any acid which gets partially dissociated when dissolved in water, it is said to be weak acid. As we took for example for a weak electrolyte, that is the acetic acid, right. So the acetic acid is a weak acid. So likewise we have few more examples for that, right. So if we talk about the strength of base now, so similar you can say the same condition applies for the base also, right. So if any substance, right, like I am writing AOH, this indicates the base, right. It is a general formula for the base. This is any you can say the metal or something like that present, and this is the hydroxide, which is the most important condition to behave as a base according to the Arrhenius. So he said that any substance which gets dissociated and produce all its hydrogen ion which it contains, that means in the solution we are not going to see AOH anymore. We'll just see the A positive and the hydroxide ion. That means there is no unionized molecule of the base present. Everything is just dissociated into the A positive and the hydroxide ion. Then it is called as the strong base. Like we have NaOH, we have potassium hydroxide, they are all strong bases. All metals which come, you can say, which come at the top of the reactivity series, they just have the affinity to combine with water, or you get dissociated when they are dissolved in water. So they just form the example for the strong bases, right. And similarly, as we did that the acid which gets partially dissociated are weak acid, same is applicable in this case, that the bases which get partially dissociated to form their hydroxide ion, they are weak bases. That means in a solution we will get to see the A positive and the hydroxide ion, and also the unionized molecule, that is the AOH. That means it is not fully or not completely dissociated into ions. So that means it is a weak base, right? So it is just a simple thing. If you get to see the unionized molecule present in the solution, that means it is a weak electrolyte, right? I am talking in terms of electrolyte. But when I use the term acid or base, as I know, a substance behaves as acid when it you can say delivers the hydrogen ion, and if it delivers the hydroxide ion, it is a base. So if it completely gets dissociated to form hydrogen ion, it is a strong acid, and if it completely dissociates to give hydroxide ion, it is a strong base, and if it partially gets dissociated to form hydrogen ions, it is a weak acid, and if it partially dissociates to give the hydroxide ion, that means the solution contain the unionized molecule, that means it is a weak base, right? So this is so simple. Just what you have to remember is that he explained on the basis of giving H positive and hydroxide ion, and moreover, if completely dissociation occurs, then strong one, whether it is acid or base, and if the partially dissociation occurs, it is a weak acid or a weak base, right? One more thing which I would like to discuss with you is that, as Arrhenius told, that when any substance dissolved in water, it produces hydrogen ion, right? But when hydrogen ion is delivered in a water, it no longer remain as hydrogen ion. You must have come across the definition in the lower standard, that you must have seen the definition in few books. You were getting that when any substance dissolved in water forming hydrogen ion is acid, right? I think you know that, right? And in few books you must have seen, or your teacher must have told you that instead of writing the hydrogen ion, write this, that any substance which when dissolved in water produce hydronium ion is an acid. Now you must be confused that whether you have to write the hydrogen ion or whether you have to write the hydronium ion. So this is the stage when you are going to learn that why your teacher used to tell you that instead of hydrogen ion, write the hydronium ion, right? Because now you are at a appropriate age to know about it, right? So just come to that point. Actually, the hydrogen ion, when an acid is dissolved in water, it produces hydrogen ion, right? So that means it is an ion with positive charge, right? And this ion has one exceptional property. Can you guess that? Yes, you are right. This ion has no electron in it, right? Because you know the atomic number of hydrogen is 1. Electronic configuration is 1. When it has lost one electron, that means it is not left with any electron. Only one proton is present in it, right? So that means this is an ion with exception behavior, that it has no electron, right? And its size is too small, or you can say almost compared to the size of the nucleus. It is almost like that. So that means it has got a strong positive field around it. It has got a strong positive, because smaller is the size, you know that the magnitude of charge is that much intense. So that means it has got a strong positive field around it, right? So what is going to happen when any substance which when release this kind of ion, a small size with no electron and with the, you can say, the intense charge in water, then it no longer remains separated from water molecule. What happens? It just bond with we know that the water geometry is like that, the bent one. So what does it do? It just unite, you can say that this positive charge is so intense that it just get attracted towards the electron, the lone pair of the bond, the water molecule, and just get bonded to it by this bond. So that is why it leads to the formation of, instead of hydrogen ion, we found the hydronium ion in the water when any substance release an hydrogen ion. I think it's clear now. I'll just repeat, and you can say in form of answer how you're going to write. So you are just going to write that yes, when acid is dissolved in water, it is not producing hydronium ion, right? It should be clear in your mind. It is producing the hydrogen ion, right? So first thing is clear, that when acid is added, only the hydrogen ion is being produced. Now what happens to that hydrogen ion? That hydrogen ion contains the intense a positive charge around it, or you can say a strong positive field around it. So it could no longer resist itself from the lone pair of the water and just get attracted towards it and form a compound called H3O positive, and they are linked by a coordinate bond. What is that coordinate bond? It is a kind of bond which is not formed by losing electrons, which is not formed by sharing electrons. It is a kind of bond in which the shared pair is denoted by only one atom. And the necessary condition is that the one molecule which is going to link with the other should possess the lone pair. Then only it is just going to share its lone pair with the other atom, right? So that is why we get to see the hydronium ion instead of hydrogen ion. I think it's clear now that what is the difference between that a substance is releasing a hydrogen ion or a hydronium ion. So it is always better to write that when a substance is dissolved in water, if it produces the hydronium ion on adding into water is called as acid. I think it's clear that why your teacher used to tell you that instead of writing the hydrogen ion, just mention the hydronium ion, right? So this is the reason behind this. Now the question comes, as the Arrhenius told about the acidic nature, that which substance is called as acidic, and he also explained that which substance is called as basic, right? Now what he said, in favor of neutral substance. So he just said that a neutral substance is that in which the hydrogen of acid and OH of base just react to form a neutral water molecule. That is a neutral substance. A reaction is called as neutralization reaction. So that is why a reaction between acid and base to form a neutral substance, that is the H of acid and OH of base just reacting to form a water molecule, we know that water is neutral with pH 7. That means it is a reaction of neutralization, right? So this is how he explained the acidic, basic and a neutral behavior, and his attempt was up to the mark, but still there were few limitations which he could not explain. So we have to look on that limitation too as well, because whenever some scientists discover something, there are many scientists just sitting around to criticize that you can say, or to just raise the question against him. So what were those questions which Arrhenius just failed to answer, right? So the first question was that he said that when any substance is added to water, he said that when any hydrogen ion is added to water, it just gets hydrated, right? So why Arrhenius said that when an acid is dissolved in water, it produces hydrogen ion, and when an acid is base dissolved in water, it produces hydroxide ion? Because we know that when any ion is added to water, it just gets hydrated. So where this the term, the ions, that how we are you can say able to see that those hydrogen and hydroxide are present in the water, right? So this was the first limitation which he failed to answer. The second limitation was that he said that any substance to behave as acid should contain the H ion, right? And any substance to behave as base should contain the OH ion. But we know there are few substances, like if I talk about CO2, you know that nature of CO2, you have done in previous classes that yes, the CO2 is acidic in nature. So how we can come to know that it is acidic? It is neither possessing that H ion and nor it has the OH ion. So from where this you can say the nature came from, which factor we came to know that yes, it is acidic in nature? And similarly we talk about the case of calcium oxide. Here also I am not able to see that hydrogen or hydroxide ion, but still we know that CaO is basic in nature. So this is the second limitation which he failed to answer, right? So these are, the third one is that we know that if we react NH3 and HCl, they are just going to form this NH4Cl, and in this reaction does not involve the water component, and he said that everything is happening in the presence of water. So that means these three limitations he just failed to answer. So this was the Arrhenius concept which I explained.